This week we're going to be looking at integration tests for web API applications. And so the application I've got here is actually the one I was using last week when we were talking about Swagger, which is just a simple RESTful API using Web API. So we've got an entity of book review with an ID, a title and a rating. We've got an SQLite database containing a few book reviews. We've got a DB context using Entity Framework to access that. And then we've got a repository interface with the various methods we need to access those reviews, and also an SQLite implementation of that. And when we run this up, we can see that we get the Swagger interface that we can use to interact with that. So I can go to, for example, the get and execute that, and we see the list of book reviews that we've got in there. And so we've got those for all of the operations. I've got some gets, a put, a post, and a delete, all of which we've got defined in the controller here as pretty straightforward methods accessing that data. And when we're developing and when we're testing, having Swagger can be very useful because it means you can take a quick look, see that everything's working okay. But in terms of more serious testing, it's very much, as we see it here, manual testing, having to open up the section, click execute, and so on and so forth. What we'd like is some kind of automated test that can go through that as well. Now, there are tools available with Swagger that will do automated scripted tests for you. Similarly, there are tools with Postman and lots of other ones as well. But they have the slight disadvantage that they're not part of your C#.NET project. You've got to learn a separate set of skills and keep them in a separate place in order to use those tests. And also, they're not really quite integration tests, they're actually end-to-end tests, because they're going to test your API all the way through to the data in the database. And that always introduces problems, because when you've got data in a database, if the data's wrong, then you'll get errors even if your actual functionality is right. And so we also would like to be able to mock the data so we know what data we're testing against. And so that's why typically we go for unit testing. And so I've actually written some unit tests here. So here we've got a unit testing library written in XUnit. There we've got the book reviews controller tests, and we can see what we've got here. So I'm following quite a common convention that people have with tests here of having 3 sections in the test name. So the operation we're going to test, the circumstances under which it's going to work, and then the results we get back. So we're saying that if we do a get, it always returns all the books. And we're using the MockU library to create just a couple of books, doesn't matter about the details, and we use that to mock the repository. But then here we've got the actual code that does the testing. So we create a controller programmatically. This is one of the key things about unit tests, that you just write C# code and we're creating a controller there and passing in the mock repository. So normally in the controller we would be injecting whatever's being configured to implement that interface, but we're not worrying about injection here. We are just passing in our mock object. We then just call the method that we're looking at, so the get in this case, and then we verify that we've got the right type of result, so an OK object result in this case, and also verify that the data that's come back matches the data we expected. And then we've got the get by ID, if exist returns a book, again some mock data, again we create the controller, call the method directly, this time passing in 2 to get the book with ID number 2, and then check everything's okay. And then also we need to test error conditions, so the next test, get by ID if missing, returns 404. And so we've only got books 1 and 2 here, but we ask for book number 3, and we should get the not found result. And then we've got a few more tests of other things. Doesn't matter too much what's going on in there. So those are unit tests, and obviously if we run those tests, then we're going to get green lights because everything's working in that case. And so that looks pretty good. But we are not testing quite the same functionality as we are when we go through Swagger or something like that, because we're directly accessing these things programmatically as we are there, and therefore anything to do with the infrastructure around that, like the routing or the serialization and deserialization of the JSON, things like that, aren't going to be caught if we get them wrong in these unit tests. And I can show you a couple of examples of that. Let's go back to the controller, and let's suppose on there I made a mistake, that on this get by ID, you can see there I've declared the format of the root that is going to pass in ID, and there I'm passing in ID as the actual parameter. But if I got that wrong, so now the name there doesn't match up with the name there, well, if I run the tests, then we still get green lights because all the test is doing is calling that function. It doesn't bother to look at what's happening in the definition of the root. Whereas if I run that in Swagger, and so there we've got our get1, now we can see it's got really confused because it's now seeing two parameters, one called ID, one called IX. The ID it thinks is part of the query string, and the IX it thinks is part of the path. If we try that one out, so if I ask for number 3 and execute that, weirdly we get a not found, and that's because if we go back to the code, the ID is the thing that's actually being used, not the IX, and the ID, which was part of the query string, we left it blank, so it defaults to 0, and so actually it's always trying to look up element 0, and so that passed the unit tests but actually had a bug in it that we didn't spot. Another problem that we can get in the other direction is the fact that our unit tests are actually locking the implementation of this controller into a particular way of doing things, which, remember, unit tests should never do. We should be simply testing the output, not how the implementation works. But if you take a look at the test for the post, then you can see that we're assuming that the post returns a created at action result. That is the correct behavior for the test. And that's okay because in the post here, we are returning a created at action. But actually, that doesn't really matter. That created at action is how we form up the return value, but there's other ways of doing it as well. For example, rather than created at action, which basically allows you to provide the name of the action method in the controller and forms up the response from that, we could use an alternative which is created at root. And that doesn't form up the name of the URL itself, you actually pass it as a string, which in this case is just going to be a blank string because we're not using named endpoints, we're just using the verb like get. So if I just put that in there, then behaviorally that is exactly the same. So if we just run up Swagger and exercise it in that, we go to the post, we'll try it out, we'll create a new review for Emma and give that a rating of 4 and then execute that. And we can see we still get the 201 coming back. We've still got the new ID of 28. So that's working fine. But if we run the unit tests, that now fails because we returned a created at root result, not a created at action result. And so although the behavior is correct, it's complaining about the way we did it. And so that's not allowed. So that's causing us a number of problems. And so what we'd like to do is get the best of both worlds, have automated tests that we can write in C#, but which go through the whole cycle of checking the roots as well as the functionality of the controller. So let's see how we do that. And what we need to do is we can add here a new project. We could do it as part of the same project, but I'm going to do a new project. So we'll add this, and this can use any testing framework you like. So I'm going to stick with XUnit, but it would work with NUnit or whatever you go for. And we'll call this the same as the overall project plus .integration tests. And then first thing we obviously have to do is reference the classes we're testing. So we'll put that in there. And then what I like to do is mimic the folder structure in the project under test in my test code. So I'll add in here a new folder called controller tests, and then I can get rid of those two, and then in here we'll add our tests of the book reviews controller. So book reviews controller tests. But then to make these integration tests, I've got to start doing a little bit of extra work. So what I'm going to do is also in here, I'm going to add a class which I'm calling custom web application factory. And it's called that because it needs to be derived from a class called web application factory. And that actually comes in from a different package. So we'll just get that automatically installed, and so that will give us that. And then this is a generic, and the class you want to pass in as a generic parameter is actually the class which configures your web application. So in our case, that is the program.cs, which is where we do all the configuration of our DB context, our injection, our pipeline, all the things that we're going to need to use to some extent or other in part of the integration test. So that's got to be there. Problem we have there though is if we try to just type in program, we can see what it thinks we're after is this thing called Microsoft.visualstudio.testplatform.testhost program, which is completely the wrong thing. And it looks like it's very difficult to get hold of the program we've got here. And the reason for that is that we have generated this project using the approach that doesn't give us the full program class with the main method. And so from the code we've got here, it's actually generating the program class, but it's generating it as internal. And that means it's not visible in our test code over here. So what I have to do, if I just inside that program, if I right click on it and go to the quick actions, you can see we can convert to a program.main style of program. And if I do that, it just generates that code. But then we can see that's what the problem was, that this program was being declared as internal. But now we've got access to the code, we can just make that public. And so now in here, that program is the program that we want. So that's got that working. Then having done that, let's copy that and go back to our actual tests. So in here, we're going to make use of that application factory. And the way we do it is this. We're going to declare a private field of that type that we'll just call factory. And then we're also going to declare a private HTTP client called _client. And then we'll have a constructor which creates both of those. The factory is easy to create. We just say _factory equals new, all of that. And then we say _client. Then we don't say equals new HTTP client. We say equals _factory.create client. And that's what gives us this kind of fake HTTP client, not connecting to a genuine web service, but just connecting to our web service in the test environment. Now, something we've got to watch out for, both of those, the HTTP client and the factory, are disposable. And so we've got to dispose of them. So we need to make the test class itself disposable, and then implement the interface. And then in the dispose, just call dispose on each one of those like that. And bear in mind the way that XUnit works, for each and every test, we will create and then dispose of the class. So this will be done once on each test. We're getting a brand new factory, a brand new client for each test, which is what we want. Having done that, we can now start writing our actual tests. And let's actually just copy them over from the original unit test, because basically we want to test the same thing. So let's go and take the first one of these, which was the one that just checks that we always get the books. So we'll grab that and go back in here, and that will be our first test. But we've got to make a few changes. Well, firstly, we've got to get hold of MockU, so that's easy enough. But actually, let's keep things simple for now. Let's not even worry about the mock data. And so let's not compare against anything. Let's just check that we got the appropriate result. But this is where things get a bit different, because we're no longer going to directly make the call to the controller. We're going to go through the HTTP client that we just created. And so what I'm going to say here is var response equals _client dot get async. That's an async function, so we're going to have to put an await on it there, which means we're also going to have to change this to an async task. And then on that get async, we merely need to put the path to where we want to go, which is /book_reviews, because that was the name of the controller without the word controller. So that's what we have there. And so that's replaced those two calls of creating the controller and calling the appropriate method. That's just going to map straight on there. And then the last thing we want to do is just verify that the response code is the OK status. And so all we need to do for that is an assert.equal and then HTTP status code. It can't find that. We've got to do another using and then .ok, and we check that is the response.status code. And so now if we run those tests, we actually get an error, and the error we'll see there is basically that it can't find the database file. So actually we're going to have to do some mocking before we can get this to work at all. So this is how we do the mocking. We go back to this factory and we're going to have to do a couple of things in here. We're going to declare a public property which is going to be a mock of our repository. So that's iReview repository. And we'll call it mock and we'll make it get only. And then obviously we've got to create that in the constructor. So in the constructor, we will say that equals new, all of that. So just normal mock-u behavior. But then the thing that's a bit different, inside this web application factory, we're going to override a method called configure webhost. And this is where we can override the default dependency injection configuration that it picked up from the program here, and we can provide our own because we want to use this mock object. So what I'm now going to do is say builder.configure test services, and that gives us a lambda. And in there, I'm going to say services.add singleton, and then review repository mock.object. So that means whenever someone asks for the iReview repository, they'll get that mock object. It may think it's a bit odd we're doing this as a singleton because more normally, say here, we do the repository as a scoped, but actually it doesn't matter here because remember this thing is being recreated each and every time because of the way that XUnit runs that around. So having done that, even though we haven't configured that mock for any actual behavior, that should just be enough now that it will be there when it's needed, and we should get the green light just saying that we got back the status code of OK, even though we didn't actually get any books. But now we can go a step further, and now we can start doing our mocking. So we'll uncomment those mock books, but now rather than creating our own repository locally, we're going to use the underscore factory dot, and then we've got that public property for the repository, and so there we're passing in the mock reviews, which means we can now also have a look at the collection there, except that it's not result.value. We've got to do one more thing. We've got to unpack that data as it came out of the response. So we'll say something like var data equals, and then we'll do a JSON convert dot deserialize object, and we'll do that to an IEnumerable of book reviews rather than an array. And then we do that on await response.content.read as string async. So that will unpack the data from the body of the response. And again, that's something we want to do to make sure that our JSON formatting is working correctly. Then finally, we just need to pop data in there, and that should all be okay. And so now that, as well as simply testing that the status is correct, we're also going to be getting the correct result. And once we've done that, we can now move on and do that for the other tests as well. So if we go back to our unit tests rather than our integration tests, let's grab the next one. So this one is get by ID if exist returns book. And the process of conversion starts to become fairly mechanical. So we still create our mocks. We don't create our own local mock repository. We just put it into the one we've created in the factory. We don't create our controller. We call client.getAsync, which of course means again we've got to make this async task. On this occasion, because we're passing in the ID, we're going to put a /2 on there. We don't need any of that. We again want to check that our response is giving us OK. And again, we want to extract the data. But in this case, we want to extract the data just to a single book review. And then we can just put data in there. And if we run those tests, we should get the second one working. And then if we just very quickly do all the remaining ones. So that was the one with the missing, the one for the summary, and the one for the post. So we'll copy those, go back in here, and it becomes really quite straightforward, as I said. So we need to change that to async task. We need to change that code there. Let's grab those. And on this one, we've just got to remember we're asking for number 3. And then we want to make sure that that corresponds to not found. And actually, I think once you've got the hang of this, these integration tests are actually less code to write them than the unit tests, because you don't have to worry about the various typecastings and that sort of thing. It's all much smoother. Here we've got the summary. So again, let's treat that a little bit. So there's our mocking going in there. And then our call is going to be to get async / summary. Again, got to make it an async task. And then we want to make sure the status code is okay once again. So let's steal that from up here, because we're going to want to unpack the data in the same sort of way, because it's going to be an IEnumerable of book reviews. So we'll pop that in there. And then once again, it's going to be the data that we're doing the tests on. And then finally for the post, async task. The mock data is much simpler, but we still want to change that to a _factory dot review repository mock. Notice what we're testing for here is both that the create method on the repository is called and that the save changes is called. So we are making both of those verifiable, and then we verify them down there. Then we're going to make our HTTP request, but this time, of course, it's going to be a post async, and then because it's a post, we need to provide a body. So there is a handy little class called JSON content. Just get that from the namespace, and that has a method called create, which will actually take our object and turn that into JSON and put it in the body, so that gets sent off. So that's quite a nice thing we can do there. And then all we've got to really do there is assert that we get the appropriate status code, which was going to be created, and then we do the verify all to make sure that everything was called correctly. So with a little bit of luck, all of those tests should now pass, and they do. So that's working fine, but those should be more robust against the problems I was talking about. So remember the couple of problems that we had. One was if we go back to the controller, if we change that to IX, if we now run the tests, then we get a failure along the lines of what we got when we tested that manually in Swagger, but that was missed by the unit test, and you can see still is being missed by the unit test. So that one is now caught, but then the other problem we had, which was the other way around, was on the post. So if we change that from a created at action to a created at root, and change that just to blank, that gave us an error in the unit tests, which it didn't give us in Swagger, and we want the integration tests to reflect Swagger, and that's what's happening. So in both those cases, integration tests seem to be better than unit tests because they catch the sort of errors that unit tests miss. So that's what you can do. You could obviously fill that out a bit and add further tests for all of the interactions. But what I've done here is actually probably not particularly smart. You wouldn't see this done in the real world, in that I've done both unit tests and integration tests testing exactly the same thing, which is duplication of code. And given that I think I persuaded you the integration tests are better, and also once you've got the infrastructure in place, slightly easier to write, I would typically just be writing the integration tests and only maybe introduce unit tests when you find a particular problem that for some reason isn't working with the integration tests or whatever it may be. But integration tests like this first, they're quite easy to use, and once you've got your web application factory working, then they really work very smoothly. So that's quite a useful technique for when you want to do automated testing of a RESTful API. You can use these tools, and it means that you're just writing C# code. You can share code, you can do your mocking in just the same way you used to, and get your tests running automatically. So, hope you enjoyed that. If you did, do subscribe, do click like, and I'll see you next time.